Welcome to your CCPS Science Review Lab. Today, I'd like you to look at these two images and think about what they might have in common. On the left-hand side, I have ocean waves, and on the right, I have an image of our sun. Wonder what our sun has in common with ocean waves. Let's take a deeper look at that. We know that within our sun and within any star, there are nuclear reactions taking place. As those nuclear reactions take place and the sun shines, energy fans out from the sun in the form of solar radiation. Solar radiation refers to the energy that the sun is sending out in the form of waves, right? We know that the sun does not, we don't plug into the sun. There's nothing directly connecting us to the sun. So how do we get the energy? It moves out in radiation in the form of waves. Now, different waves take on different forms. A wave that might be long might have very low energy, and short waves might have very high energy. If we look at this model here, we see the sun and the earth, and we see that the energy from the sun is fanning out in all directions, right? It's not just coming specifically at the earth. It's fanning out in all directions. So most of the sun's solar energy or solar radiation is lost in space. We have some, though, that does head towards Earth. Our clouds and ice may reflect some of it back, but then some of that radiation makes its way to Earth's surface, okay? And that's what drives all our natural processes on Earth, like photosynthesis, water evaporation, weather. All of those processes are a result of incoming solar radiation. Now, we said that solar radiation travels in waves. Those waves are examples of electromagnetic radiation. Some of them we can see, that's the visible light, and then some of them we can't see. Examples of that might be infrared radiation or ultraviolet radiation. The important thing to remember, though, is that all of that solar radiation is coming through in the form of waves, and that those waves have different length. You can see the length of the different waves and different frequency. Okay, so the big ideas are solar radiation sends energy in the form of light and heat to Earth in waves, and those waves have different wavelength and different frequency. Okay, now's your chance to show what you know. I would like you to copy this diagram as best you can into your notebook and give me 3 sentences that describe how solar radiation moves from the sun to the earth. And maybe for a little extra credit, include in there 2 processes on Earth that solar radiation make possible. Good luck!